So the
Okay.
metadata also will be stored in micropartitions.
Come again.
So the metadata will also be stored in the form of micropartitions.
Oh, you are saying metadata is stored in the form of micro partitions, right?
Yes, yes.
So metadata is like information about the data. Like every micro partition Snowflake stores metadata. Yes, micro partitions in Snowflake store the metadata. So it's columnar data, right? So what is the difference between like micro partitions and metadata? So metadata means like so minimum values, smallest values, maximum values, largest values. Okay. So number of district values, null count, data type, compression information. Suppose my partition having so tables, different tables. Okay. When we run the any query, okay, so it won't scan. Okay, only the if any query related to the like sum of average, it will scan the table and it will do sum and average. But when we run query about like a count, okay, and where date like that, it's going to take by the metadata. So simple, you can say like Snowflake stores metadata such as minimum value, maximum value, number of distinct values, so null count, data type, information, and compression metadata for each column. So the optimizer uses the metadata for partition pruning, so reducing the amount of data scanned and improving your query performance. Okay, so it means like simple micropartition Snowflake stores metadata. It means like in the format of micropartition going to store the metadata. So it means the micropartition is going to have the metadata. Clear? It's inside the micropartitions.
Yes, sir. Yes, got it. Understood, understood.
Yeah. So okay, here what we do. We started record.
I don't think so. It's recording.
Yeah,
I
let's
think it's
start.
recording. Yeah, now it's recording. Okay.
Okay. So this is how okay they ask about micro partitions because of so many interviews are given. So 80% successful. They told like an interview, okay, we're going to release the offer letter. Okay, but they have not received. Why? Because of uh, so someone giving better than. So that's why I change every pattern. Okay, way of answering. Way of answering I change. Why? Because of so while you're answering the any question, you need to tell about related to the your resume project. Suppose you have the bank project or power project or healthcare or retail or any business projects. Okay. First, suppose you have the bank, you need to tell, okay, in my bank transaction table. So when we count off account IDs, how many customers are there when we're counting. So it scans from the metadata. It won't scan the table. It gets from the metadata. So like that, we need to explain with the computer. Do not tell definition. So when we run the query like count, it will scan the metadata, not like use, okay, because of our script. So I given more than 200 plus interview supports. Okay. So now after that, everyone, my students are getting the offer letter. Okay. So try to put your last project bank. Okay. And try to put USA UK candidates like power projects. Suppose if you have bank projects, you can go with the bank. But in your organization, if there is no bank, go with the power project. So in India, healthcare, first, last project, bank. In outside, before bank, after last project is like power project. So if there is a bank requirement, you can put bank if in your organization. Okay. So no worries, as the requirement, I will create your resume. First, you need to create the resume, share with me, I will modify it. Okay. So directly, if I create the resume, I don't have every details of you, right? So what you have the current resume, share with me and create. Okay. So when you're going to create the interview, after taking the mock interview, not before, take the mock interview first, then go with the resume, now query, LinkedIn others. Okay. So this is and so where we are, we have done with here, right? Okay. Micro partition one, minimum value, maximum value, number of distinct values, number of value values. Okay. So it's going to skip this partition because of January 8th, we have in this field. Okay. Tax date is January. It will skip this. It will going to scan this and that is partition pruning and query pruning. And so main topic is why nature cluster tree works initially. The Snowflake. Why natural? Okay, nature clustering works initially. So what is a natural clustering? Anybody have a guess? Do not browse. Okay. So see, so nature clustering is highly efficient when data is going to the in constant order. So suppose you think the retail bank loads one day's transaction every night. So data errors like first John, second John, third John, fourth, and fifth John. So each days the data going to occupy so a small number of micro partitions. Okay. So when we run query like select star from transaction fact table, so where transaction date, so need to scan only the relevant partitions. That is, you can say resulting in like fast and execution. So if you have the proper micro partitions, okay. So it's going to scan the only relevant partitions. When we 2026 John thought, so it will scan the relevant partition and the result going to be far low, like low time and fast execution. So when nature cluster start to break, so all the systems close. Okay, like for example, we have the core banking system CBS Vinity card, ATM transactions, internet banking, mobile banking, UPI payments, and credit card systems. So these systems continuously send data throughout the day. So records for, because of if I go outside, I do one transaction. Okay. If I go to another shop, I do again one transaction. So within fraction of second, we're going to receive so to our mobile number, so deposit amount dot created within the fraction of second, right? So how it is happening? So from this system, okay. So these systems continuously send data. So throughout the like day, so records for different dates have become like going to mix it across many micro partitions. So instead of partition containing only one date range, so each partition may contain like a wide variety of dates and branches. Suppose we have monthly 4 weeks, right? So 1 to 7th one and 8 to 14 and 15 to 21, then 22, 28, then maybe 20, 30 going to be one partition like that. So because of that, this increases the number of partition, right? So every day we going to receive and we need to handle last 10 years of data. Suppose if any person goes to bank, so please give me my last 10 year transaction data. They're going to provide, and even we can download from our uh, mobile through login into our account and those things. Okay, this thing. So I'll give one example of banking data. So we have one table like tax and what is the fact here? Transaction fact gold. So I have written one table name. What is the meaning? Anybody? Not new guys. Any?
It's a fact table, right? It's a fact table. Fact
Yeah,
table is the central table.
yeah.
Star schema is the fact table, and then you have dimensions.
Yeah, okay. So TX and transaction table, it is a fact table. Then what is a gold?
Gold layer, I think, is the last layer. Last layer, I mean, it's like raw
Yeah.
layer, staging layer, and then your final layer, mart
Yeah,
layer,
we have the Medellin architecture,
gold
right?
layer. Right.
Silver, bronze, gold.
Bronze, silver, and gold. Yeah. So
Yeah,
that's
yeah,
the gold
bronze,
one.
silver. Yeah, we have three, right? So bronze, silver, gold, like that. This we have the transaction table. That is a fact table, and then it is a gold. Okay, a gold layer. Okay. So here we're going to have okay 2.1 billion records. Okay, 2.1 billion records. So do not when a newbody or new guys, do not worry. So while we go with 1 week with the classes, then you will get everything. Okay, I'm telling like from scratch. Not I can close in a cluster key micro party within the 5 minutes, but you can't clear interview and you're going to be in the layoff. Okay, take time. So I'm taking the time. Okay, and giving follow me, and nobody submit to the test. Okay, I will tell you end of the day. Okay, end of the class. So 3.2 be data. Okay, 2 point. It means like 2.1 billion records we are receiving. So that is storage is like 3.2 B data. And here in Snowflake, what is the cost for 1 TB? Anybody guess? It's be like we need to discuss, not I'm teaching or you're listening. You won't learn anything. So what is the cost of 1 TB data in Snowflake for 1 month? $23.
$23.
$23. Okay, in for 1 month, 1 TB. So and this is only storage data. Compute cost is different. Okay, and time travel is different. Okay, and this having the 10 years of transaction transaction history we have 10 years of transaction history we have. So now I'm running there is like fraud team. Okay, we have fraud team. So in banking, so some people are going to do fraud transaction wise. So from fraud team, what they will do, they're going to run select, okay, from sorry action, okay, and table name, and here they're going to use, okay, where, okay, uh, going to account ID, okay, equal to say 721 821, okay. So and they're going to add and, okay, then here they're going to have what, okay, and the transaction date. Okay. So again, they use between. You need to have every knowledge and SQL commands I will explain on Friday. So you can revise if you already know, no worries, but you can revise the concept, how to use a number function, substring. Okay. Those are useful in the when while we are masking the data. So per PA data, personal information, and 01 between, and I'm using again, and I'm going with again one more date. So 2026, and again it comes like June 30. So you got it right. So do not confuse. So I will read it again. Okay. So select start from transaction fact goal where account ID 781, transaction date, and between to January 1st, June 1, June 30. It means so my account number is 72181. I need my transactions from the 2020 January 1st to January 30. So now I'm selecting data from the table here. Okay. So I need my data, okay, 2020 January 1st to and 2020 January 30. So if you run this query, my transaction details from January 1st to January 30, I am going to get it from that transaction fact table. So this is going to query run by the, see,
January or June, sir?
come
It is
again.
06. It is June.
Sorry,
Zero
June,
six.
June, June, June. Okay,
Right.
June 1st. Okay, June 1st to June 30. So we're going to run fraud. Then here we have the RBI report. How RBI report going to take this one? Okay. So they going to run same chain query. So select start from gold here, and again they're going to use where class. Okay, where. Then again here they go with like branch ID, branch, okay, ID. So equal to 104, and they go to and, okay. So again they go to transaction date. Again they use between. I will explain query. Everyone familiar with the SQL, right? So out of 10, minimum you need to have the 6. If you rate yourself out of 10, minimum 6. If you know the commands now, it's okay. I will keep so many things I have files. So with my classes, you can clear both SQL and Snowflake. Okay, here 1301. Okay. So again comes date. Yeah. One more date I'm giving like 2026. Okay, June 30. So let's okay. So what is the RBI report here? So this is about me. So using my account ID, but RBI report. So this is that I'm going to check individual details because of one person going to the fraud transaction, right? Not everyone. And here RBI report. Not to know in the specific of Chaitanapuri branch in Hyderabad. So, what is the transaction happen in the date of June 1st to June 30? So, to check those details, select star from transfer fact goal where branch ID, the Chaitanapuri branch ID is 104 and transaction date between 2026 June 1st and 2026 June 30. Then we're going to get all details, not only my details, everyone who has the account in this Chaitanapuri branch having the hiding branch ID 104. So initially, what is how going to happen here? This query going to be run quickly. So why? Okay. So after years of continuous CDC load and updates, relevant rows become like thousands of micropartitions. The optimizer must scan for more data, increasing query time. Okay. So these will explain while we go with the incremental loading. If you explain, it's going to be confusion. So see again, I will I will tell again. After years of continuous like CDC change data capture, streams loads and updates, relevant rows become scattered like across thousands of micro partitions. Okay. So the optimizer must scan for more data, so increasing query time. Okay. Initially, when we have that data, so this is I'm running data only to the 26 to June to June 30. But if I run 2016, 2016 to June 1st to present 2026, June 30, it will take time, right? Because of we have 2.3 billion records and 10 years data. So you have 2.1 billion records, 10 years data. That is 3.2 B TB data. So one thing, okay, is different data, and it's going to take time. It's going to take the compute cost. Okay, so this is how the data works. Okay, so how do we need to optimize the query? How we need to get quick result? Okay, these things. Okay, here advantages of natural clustering. So one is automatic, no configuration required, and no additional serverless clustering cost, and good performance for append only data, and effective when load order matches query patterns. Simple to manage, suitable for small and medium sized team. Okay. So simple advantage of nature cluster. Nature cluster means Snowflake handles, not we. By default, Snowflake, when we load data in Snowflake, it's going to done by the only Snowflake. We don't do manually. Suppose if you go with Oracle or SQL Server, so there are indexes we need to do them manually. But here we don't do anything manually. By default done by the Snowflake. That's why every company, every person changes the technology to the Snowflake. Okay, and not only this one, many things architecture. Okay, see, automatic, no configuration required for this thing. Okay, for the nature question, no additional server clustering, no clustering cost, good performance, depend on the data, and effective when load order matches like order date, and effective load order match, and simple to manage, suitable for small and medium sized states. And limitation of cluster. So when we go with the update, delete, and the merge operation, so this is and the continuous CDC approach streams, okay, and partition putting less effective, okay, when you have the more and CDC approach, incremental data, because incremental means today you are receiving 1 million, tomorrow you are going
So
to receive
you can. give us like this an example, because I didn't really understand the CDC and all of that. I mean, how
That
clustering
I told you,
key is a
right?
benefit,
CDC,
advantage, or
uh,
a
yeah, got it.
disadvantage?
CDC, yeah, CDC. While we go the incremental,
Change data capture. Yeah.
yeah, that we will go with the incremental later. I will explain in depth on that time.
Mhm. Okay.
Okay, okay, I will explain. Okay, 1 second, I will explain. Okay, so first go with this thing. Okay, so CDC loads and partition pruning becomes less effective. Queries scan more bytes, wherever rate comes more increase, and performance will not declares for large tables. Okay, so what is the CDC here? So I will tell you. So day one, okay, I'm receiving the 1 million records. Uh, 1 million records. Okay. So I'm creating the so think like sales table. I'm creating sales table, the retail packet. So I'm creating sales table. I'm loading. Okay. So day two, I'm receiving 1.2 1.2 million records. Okay, this is a new data. Plus, with this same the same file, I'm also going to receive okay old data. See, already see date what I'm receiving 1.2 million records new data and plus 1 million records this first day data in the same file. Now what is the data? Here 2.2. So what I do next day, I have sales tip already. So there are a few options like drop, okay, truncate, TRU, TRU, truncate, and create or replace. So without these three, if you load this 2.2 records again, it's going to have 1 million records, duplicate records in the data, duplicate records. 1 million are duplicates. So that is again we need to write delete the duplicates, right? And one more thing. So 1 million taking 2 minutes, taking think like $2. And again we are loading second day 1.2 going to take 2 minutes, some dollars, point zero $2. And again we need to pay for 1 million records, $1, $2 extra we are paying. Okay, because that taking the time, right? So one day 1 million records we are loading, take okay 2 minutes, okay 2 minutes, $2. Okay, this is a as example I'm telling, real time is different. Okay, and second day if you load it will take 1.2 $2.2 plus again same data we are loading, for that it's going to take $2. So totally we need to pay $4.2. Okay, this is not good, right? And it takes a time and cost. So, and it's going to even duplicate data. Again, we need to run the deleting duplicate values. Duplicate. Again, we need to pay. So maybe it depends. Like think like $1.5. $1.5 we need to pay for what? Compute cost. Compute cost. If the table having the time travel period, if the table has time travel period, maybe 30 days or 90 days. So think like 90 days, maximum days we are giving, and we need to pay for this $5. So same data while we are receiving, we are paying the here 2, 3.5, $8.5 extra we are paying. 8.5 extra we are paying. So that's why what we need to do, we need to go with the drop, truncate, create a replace. What is the best approach here? Suppose if we load without a drop, truncate, or create a replace, if we load same data, it's going to be duplicate and we need to pay $8.5. So this is a as example, I'm telling, in real time the charges are different. The 1 TB, 20 dollars is good. Okay, that is good, right? This is just an example I'm explaining. So here, see, what is the approach of you? If you are receiving same data, what are you going to do? What we do
Truncate
if
it.
yeah, if you drop,
Truncate.
yeah, if you drop, it's going to have in the in the time trial period. If you create or replace, still we going to have the time trial period. So time trial period. So we need to truncate the data. It's going to empty the table. Then we need to load again. We need going to have the unique data. So this is day two. Now we go with day three. So what is happening? I'm going to receive 1.5 million records. So and plus old record for day one, day two records are 1.2 plus million, and day one 1 million. Okay, where 1 million. What is the total of 1 million in the single file? So totally 2.7, 3.7 records we're going to receive. 3.7 total. 3.7. So what is the approach again? What we need to 3.7 million records. What is the approach now? What we need to sales table to truncate, speak out, truncate and load. Truncate and load. Okay. So like day four, day five, after 5 days, 5 months, we're going to see 1 billion records because 1 million records. So like that, it's going to do 3, 4, right? It's going to increase. So it will take the time and cost. So we are paying for the same data again and again. This approach is not good, right? So to avoid these, we have streams, CDC, change data capture, merge, okay, and task. Here we're going to create source table, okay, and on this top of this table, I'm going to create stream. So one more thing I have missed one concept here. So we are receiving day one, day two, day three, right? So in day three, what is happening? So I'm buying the laptop. So for the 70,000. So, but I see offer. Offer is not applied. I go to shop again. So I check with the offer, but you didn't give the discount. So please provide me the 20,000 discount. Suppose now 70,000 updated to the 50,000. So this is updated record and bought the laptop that is not performing well. I'm going to give the return and I'm going to collect the, I bought 8,000 laptop. Then it is updated to the, so what is happening? Uh, Here this laptop I bought 80,000. So, but that is not good, not performing well. So, okay, now I'm going to return this one. Okay, so what is going to delete? It means what is happening? These one point these 1.7 are insert new records, new. Okay. So these are old, right? 1.21 million are old. These are old records. All our previous data are old. So this 1.1 million new records we insert. Here 70,000 change to 50,000 update, and here 80,000 delete. You return the one. Okay. This is insert, update, delete. Okay. Remember that word insert, delete, update happening. Then it's going to capture. And for that, we need to update and we need to insert new data. We need to update new data. We need to delete the if it is deleted in the sales table. Okay, so like that. So what is CDS will do? We going to have source table. Okay, so that is sales table. Okay, sales source table and stream sales stream table, sales stream table. Still again. And we're going to create this stream table on the top of source sales source table. Okay, and we're going to have the sales target table. Okay, so first I will go with the sketch. I'm not typing. So initially, first we load the 1 million records in the source table. So we are writing the stream on the source table. This table going to capture. In this stream table, we're going to have metadata dollar is action, metadata dollar is update, and row ID. 3 columns, extra columns. Suppose in sales table I have ID, customer ID, card ID, payment, what is the date, price we have. When you and 3 extra columns we're going to have. So ID, name, salary. With that, we're going to have metadata is action, metadata is update, metadata is row ID going up. So in stream table, we're going to have in that column, we're going to mention that is insert false or true, update false or true, delete. Okay, like that, we're going to delete or insert, update. Okay, we're going to have those things in that one. Okay, So it's going to capture the stream going to capture the 1 million records, and it will while running the stream, it's going to load into the target table unique data here. So how that loads, we're going to write a merge statement with this stream to target table, because of every data in the source table, we're going to have a stream. How we going to have it going to capture. So after running the merge statement, it moves to a target table, and the stream table going to empty. So first day we load 1 million. Second day we're going to receive 1 million plus 1.2 millions. Again, what is happening? It going to capture. Okay, 1 million is the already we have the duplicates. If we load, it will think stream will think, okay, it will think like, okay, if already the data in the target table, if I load same data, it will be duplicate. It will skip 1 million. It will load the only 1.2 records unique data. Okay. Then again, third day, when what streams think, okay, 1 billion already there, 1.2 already there, the new data 1.5. Okay. So what is the new data? Third day. Third day we have 1.5. Okay. The new data is okay, 1.5. It will think and it will load only 1.5. So in finally in target table, how many records we have? So in target table we have the so 1.5 totally 3.7 million records, okay, without duplicating. And if anything happened like new inserted, already done. If anything updated, you're going to update. If anything deleted, delete. You go delete. So 3.7, maybe like 3.6 some billion because of some were deleted, right? So if anything insert, update, delete happen in the table, it's going to capture, it will load into the this sales target table unique data. And I'm going to have the create Snowpipe for the continuous data, right? So every time we don't run stream, right? For that, we're going to write top of and this meta statement, we're going to write the task. We're scheduling. Suppose I'm receiving data for hourly. I'm going to schedule for every 1 hour. This team should must need stream should run. But usually we're going to give 12 hours or 24 hours or 1 day. Why? Because of so every night time we're going to receive the data, right? So morning, evening, then close 5 o'clock, and then night we're going to receive the file. So every for 24 hours we're going to run this task. So this is clear. This concept CDC. Any doubt?
Yes, yes, yes. Theoretically, little bit,
Yeah,
yeah.
clear, right? Simple. Okay. First day I'm receiving 1 million records. Second day I'm receiving 2 million records with old and new data. Third day I'm receiving first day, second day, third data. So if you load same data, it's going to be duplicate. So what we do first, initially we load source table. Streams captures the duplicate data. It won't load duplicate data. It load only new data or new updates, new deletes. It will delete from the target table. It means in the target table we're going to have the unique data. So after running the meta statement, we do not have any data in this. And source table going to have the raw data. So clear, right?
Yes, yes.
Yeah. So do not worry while we doing the practically, right? When we go with the incremental, okay, like architecture, we are running, we're going to connect the DB, right? So while doing these things, okay, you're going to understand everything, okay, while doing the practical, okay. So now where we are, okay, table, okay, this one, okay, this going to see branch wise and this thing like this one, okay. So here, what is the best practices? So Snowflake use nature clustering for small tables. Here, monitoring query performance, tables is grow and checks byte scan the query profile, uh, system clustering depth to evaluate clustering quality, and only consider like clustering when natural clustering is no longer supports efficiency pruning. So we go with clustering. Okay. So data stored in the orders, so loaded efficiency next clustering key, overtime, DML, random, so clustering keys. Okay, tomorrow we're going to see clustering and reclustering. Then if we have that time, we're going to create a Snowflake account. So yeah, that's not clear, right? We covered what is Snowflake, what is the data, what is the project flow, what is the workflow, what are the layers, what are the environments. So everything is basic thing, not in the basic thing. And with our Snowflake architecture, micro partition and nature cluster key, tomorrow cluster, recluster. And this is the first time I think every people listening about nature cluster key. You have seen about cluster key and reclustering. What you have not, maybe you have not heard about nature cluster key. You already have worked with the Snowflake. So nature, we have the nature cluster key also inside the Snowflake. That is a behind. Clustering is the, we can see on the screen, we can create, but nature cluster is behind. So while explaining about micro partition and these architecture, you need to use this what we have nature clusters key. Then you will think, okay, or you are good and you have so knowledge, you real time have experience on Snowflake. Okay, so got it clear, guys. So we will end the session. So evening 8 p.m. today, IST, the DPT going to start. So Harita, Sam, Satya, Shabat, Venkat Prasad. So, okay, thank you. And write the test. If you do not write the test, there is no use. So I'm giving everything behind, right? So go with. So thank you. Have a great day. Okay.
All right.
Yeah. Bye. Any
Thanks.
doubt you can.
Thank you.
Yeah, you can ping me in the group. Okay. If you have any doubt.